The last template in IODB, this is also IODB template, that is integer composition. What is this integer composition? The definition is very simple. This is the definition of integer composition. What is a composition of integer n? If I give you some integer n, some positive integer, actually this should be a positive integer. If I give you a positive integer n, then what is the composition? The composition is basically writing n as sum of sequence of positive integers. So for example, what is a composition of 3? What is composition of 4? Let's find out how many composition of 4. So composition 4 means what you do, composition of 4. See, read the word itself is telling you composition. Okay, like which things can compose? Composition means summation. Composition is like a summation. So you can notice composition of 4. So this is a composition of 4. This is another composition of 4. This is another composition of 4. Okay, this is another composition of 4. 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 So these are the compositions of 4. Is it clear? The definition of composition. Remember, these are different compositions. Remember, these are different compositions because in the composition order matters. In the composition order matters. Integer composition. In this integer composition order matters. This is ordered. This is ordered summation. This is ordered summation. Remember, this is a ordered summation. Is this clear? Integer composition, in the integer composition, the order matters. This is integer composition. We will also study integer partition. Do not worry about integer partition. I will come back to that integer partition. That is a different problem. Okay, right now understand integer composition. So this integer composition, this is an ordered summation. This is an ordered summation. Order matters here. So for example, you can note these are the compositions of 4. Okay, very simple. These are the 16 combinations of 5. This is a combination of 5. This is a combination of 5. 1, 4, 1, 4. These are two compositions. 3 plus 2, 2 plus 3. Okay, these are composition. So like this. So total 16 compositions you have. Now, just tell me this question. This is my question. The set of compositions of 6 in 3 parts. In 3 parts. What that will be? The set of compositions means how many compositions of 6? How many compositions of 6 into 3 parts? How many compositions of 6 into 3 parts? Composition is ordered. This is, what is this? This is basically ordered. This is your ordered summation. This is your ordered summation. Remember, this is ordered summation. So what you want? You want 3 parts. This is what you want. You want 3 parts. Okay, you want 3 parts such that a plus b plus c, that should be equal to 6. This is ordered. So tell me, is this IODB template? Is this IODB template only the number matters? Like which number you are putting here? Yes or no? Only the number matters. Only the number matters here. Which number you are putting? Which you are putting, that only that number matters. So this is your IODB template. Because this is ordered summation, this composition, this is the ordered summation. So you have a comma b comma c, so that a plus b plus c, that should be equal to 6. But a should be greater than equal to 1, b should be greater than equal to 1, c should be greater than equal to 1. Because remember, we want 3 parts. Remember, we want 3 parts. So for example, if you have composition of 4, if you have composition of 4, then you can notice that this is a composition. In this composition, we only have 1 part. In this composition, we only have 1 part. In this composition, we have 2 parts. In this composition, we have 2 parts. Okay. So in this composition, we have 2 parts. And you can notice 3, 1. In this composition also, we have 2 parts. You can notice in this composition, we have 3 parts. So total, we have 3 parts. Okay. And finally, in this composition 1, 1, 1, in this composition we have total 4 parts. Okay, so remember In a composition, this must be non-zero. Everything must be non-zero. In the definition, you can check. In the definition, you can see positive integer, summation of positive integers, summation of positive integer. So this composition is basically summation of composition of n. So remember, composition of n, that is basically ordered summation of positive integers. That is ordered summation of positive integers. Summation of positive integers. This is important. Positive integers. Zero, you cannot allow zero. Like you cannot put zero. Don't say that this, remember, this 5, 0, 0. This is not a composition. This is not a composition. Okay, this 5, this is a composition. But 0, 5, 0, this is not a composition. Is it clear? For example, 5, 1, like I can say 4, 0, 1, this is not a composition. 4, 1, this is a composition. 1, 4, this is a composition. Is it clear? Is this the definition of composition? Is it clear? The definition of composition. Composition is this is the definition. This is a ordered summation of positive integers. Of positive integer. This is the composition of n. Ordered summation of positive integers. Now let's see this. So you can notice here we want 3 parts. Exactly 3 parts we want. Because we want 3 parts. So a should be greater than equal to 1, b should be greater than equal to 1, and c should be greater than equal to 1. So here now what will be the answer? So basically 3 are gone. So 3 are gone. Now what is the remaining stars? Remaining stars. 3 are gone. So remaining stars. That is total 3 stars are remaining. Total 3 stars are remaining, and there are 2 bars. 3 stars, 2 bars. So the answer will be 5C2. This will be the answer. 5C2 will be the answer. Okay, remember, note this. This is important. That because every part, A, B, C, every part should be greater than equal to 1. It cannot be 0. So the answer will be 5C2. What will be the answer for this? The set of composition of n into k parts. Into k parts. So total you want k parts. Like this type of thing is there. Total you want k parts. There must be k parts. There must be k parts. And the summation should be equal to n. The summation should be equal to n. Total you want k parts, and the summation should be equal to n. This is your equation, such that every bi is greater than equal to 1. So how many remaining stars? So tell me how many stars will be remaining. Means I can ask you how many stars will be remaining. How many stars will be remaining? So that will be n minus k stars will be remaining, because everyone, to every child, this is a child, this is a child, this is a child. To every child you give 1 1. To every child you directly give 1 1. To every child you directly give 1 1. To everyone you directly give 1 1. So these are the remaining stars. And how many bars are there? So that is very simple. K minus 1 bars are there. So what will be the answer? What will be the answer here? That will be n minus k plus k minus 1. So that will be n minus 1 c k minus 1. N minus 1 c k minus 1. Or I can say n minus 1 c n minus k. That is also fine. N minus 1 c n minus k. That is also fine. But this is like, okay, this seems better. This looks better. Okay, is this clear? So here we will take a note actually, because many times this is important. Many times this is important. So let's take a note. So whenever you have this type of equation, like, okay, this type of equation like b1 plus b2 plus b plus bk, maybe br, this is equal to n, such that bi is greater than equal to 0. Then what will be the answer? Then what will be the formula? And when you have this, and bi is greater than equal to 1, means everyone should have at least 1. So in this situation, the formula is very simple. So total n stars plus r minus 1 bars cn. Okay, in this the formula is like this. So you have total, you can notice, okay, very simple. You have total r minus 1 bars, and total n stars. So the formula will be like this. And here what will be the formula? Here the formula will be n minus 1 r minus 1. Just check it. Is it the correct formula? Okay, so here basically the bars will be r minus 1 and the stars will be n minus r. Bars will be n minus, okay. So here what will you get? Total is n minus 1 cr minus 1. This is same as n minus 1 n minus r, but this formula we will, okay, because many times frequently this is frequently used, this formula is frequently used, n minus 1 r cr minus 1. Okay, whenever you have this situation, whenever this situation you have bi is greater than equal to 1, bi is greater than equal to 1, then this formula we have n minus 1 r minus 1. Okay, but anyway, you don't have to remember it, because if you remember it you will make mistake. Okay, someday you will make mistake. If you remember it, then someday you will make mistake. Okay, so you can just apply the formula, the procedure. Just find how many bars are there and just find how many stars are there, and then it is very simple. Okay, total C stars. So that is the idea. Now let's see this question. So if you have a positive integer, then how many compositions are there? Okay, this is my question. This is important question. Like if you have a positive integer n, then how many compositions are there? Positive integer n. You have positive integer n. How many compositions are there? How many total compositions are there? Now I am asking total compositions. How many compositions are there? So what will you do? If I ask you how many compositions are there, then what will you do? Just find k parts, and that k can go from where to where. See what you can do. How many compositions are there? How many compositions are there? So just find out r part compositions. Just find out r part compositions. So how many r part compositions will be there in which you have r part? In which you have r part. Okay, so that will be n minus 1 cr minus 1. That will be like this. Okay, yes or no? And this r is going from where to where? Because I am asking how many compositions. So this r is going from where to where? So total number of compositions. So total number of compositions, what that will be? Remember here this is r part composition. Here you have r part, total r part you have. Okay, now I am asking total number of compositions. So total number of compositions, this r can go from where to where? This r can go from where to where? This r can go from 1 to n, because everyone should be at least 1. In this composition, a comma b comma c comma whatever composition you have, okay, whatever composition you have, these values must be greater than equal to 1. These values must be greater than equal to 1. Okay, anyway, so using this idea you can do. So first find how many r part composition are there. These many r part composition will be there. Now total number of composition, just sum all of them. R is going from 1 to n. Okay, so what this value is? Anyone want to tell me what this value is? R is going from 1 to n minus 1 cr minus 1. What is this value? You can also do like this. In the fundamental course, Sachin told you, right? Sachin told you, like we can change the range. This range we can change. If you want, you can change this range. So you can say that you can put x here. You can put x here. Okay, then tell me where this x will go. You can put x here. So x will go from where to where? So you remember, you are putting r minus 1 equal to x. You are putting r minus 1 equal to x. So if r is going from, when r is 1, then x is 0. And when r is n, then x is n minus 1. So r is going from 1 to n. So x will go from 0 to n minus 1. Now this is your favorite. Now what is this? Summation of all the coefficients. This is summation of all the binomial coefficients. So that will be 2 power n minus 1. This will be summation of binomial coefficients. Let's solve this one. Just expand. Just expand it. Expand it. What you will get? If you expand, put r equal to 1. Put r equal to 1, what will you get? If you put r equal to 1, then you will get n minus 1 C0. Put r equal to 2. Put r equal to 2, you will get this. Put r equal to 3, you will get this. Put r equal to n. Put r equal to n, you will get this. So what is this? This is a summation of all the binomial coefficient. But here you have n minus 1, like n minus 1 C0, from n minus 1 C0 to n minus 1 Cn minus 1. So that will be 2 power n minus 1. So this will be the number of total compositions. So if you have a number n, if you have a positive number n, then total number of compositions will be 2 power n minus 1. This is your IODB problem. This is last IODB template. So we have seen this. Now, complete analysis of IODB we have done. I promise you, there is no standard problem that we have left out. Every standard problem we have taken. And in the GATE exam, most of the time, they only ask standard problems. Okay, most of the time, they will only ask standard problems. So all total 7 problems we have seen now. Now you can notice integer composition of n, that is same as IODB, with number of boxes varying from 1 to n. You can notice, yes or no? Yes or no? Number of boxes are varying from 1 to n, and every box contain at least one object. This is your integer composition of n. This is the composition problem, integer composition of n problem. Okay. So did you understand this integer composition? Anyone has any doubt in this? Anyone has any doubt in this? How many integer composition are there? Total, how many integer composition we have? 2 power n minus 1. Anyone has any doubt, or did you understand? Basically 1 part, 2 part. So you are doing the summation, and so on n part. So you are doing the summation. Okay, and this is the final conclusion, that integer composition problem is same as IODB problem, where number of boxes are varying from 1 to n. Number of boxes are the parts. You can notice number of boxes. What is number of boxes? That is your number of parts, right? Yes or no? That is your number of parts. Number of boxes is your number of parts. Okay, and every part should have at least, every part should be greater than equal to 1. What is the answer for this question? Number of ways k votes can be distributed to n candidates. There are total k votes. You want to distribute them to n candidates. Which problem is this? DODB or IODB? Is this DODB or IODB? Votes are same or different? In any election, votes are basically like there are 10 votes. It's like there are 10 votes. Only number of votes matter to you. Yes or no? Only number of votes matter to you. The only thing that matters to you is number of votes. That is what happens, right? So you can notice number of ways k votes can be distributed to n candidates. So this is your IODB problem. So total k identical objects you have. So the answer will be, these will be your stars, and these will be n minus 1 bars. Okay, so this is your IODB problem. The answer will be n plus k minus 1 ck. And what about this? What about this? So that at least everyone receives at least one vote. Then here the answer you already know, that is total n candidates you have and total m votes you have. So that will be m minus 1, n minus 1. Okay, this will be the answer. M minus 1. See, this is wrong. N minus 1, m minus 1. This is wrong. This is wrong. Can you notice this is the problem with formula? Don't remember the formula. Apply the method. See, in the GATE exam, you can take 30 seconds more, but correct question. But correct the question. To save the time, don't wrong the question. Okay, is it clear? So very simple. Here total you have m votes. See, these are your m votes. So these are your stars, and total n minus 1 bars you have. But everyone should have at least one vote. So how many remaining stars? So just find out remaining stars. So remaining stars will be m minus n. This will be the remaining stars. Now remaining stars are m minus n. So the answer will be m minus n. These are the stars plus n minus 1. These are the bars. C m minus n or n minus 1 or n minus 1. So that will be m minus 1 n minus 1.